All right, can you hear me back there? Fantastic. All right, my name's Jeremy Cox. We'll be talking about understanding multi-factor authentication. This is a basics talk, and hopefully we can cover some of the basics. We will talk a little bit at the end of maybe some implementation. There's not going to be a lot of implementation. This is basically explaining how multi-factor authentication works, the pitfalls associated with it, some of the issues that have become more known recently, especially concerning text messaging, and some other things. So we'll get into it. But like I said, my name is Jeremy Cox, and my slides have frozen. You know, there's nothing better. Somebody has totally knocked me off. My name is Jeremy Cox. I work for Washington County School District. And at Washington County School District, I'm the network manager, and I'm also in charge of security. I also am on the SAINTCON committee, and I'm a DEF CON goon. So I'm happy to be here. I love doing what I'm doing. I love being part of this great community, and we love putting this conference on for you. And we hope that at the end of the day in this conference that you're going to get something out of it that you can take back to your organizations and that will help you and help your organization. So let's talk about multi-factor authentication. So the basics. So multi-factor authentication involves the use of more than one of the following three things. Something you know, in other words, a password, a PIN number, something that you are, like biometrics, and something that you have, hardware tokens or smart cards or many different things. So something you know, this means a password or a PIN. And for a lot of users, it's something this simple. In fact, this seems to be a common issue that we run into, is that we have users that have super simple passwords, and how do we deal with that? Because as we get into more and more passwords and more length, how do we deal with those users that can't remember it? Well, they write it down somewhere, they lose it. There's all sorts of issues associated with it. So something that you are, that could be a fingerprint, a retina scan, or a facial scan, as we've recently found out, sort of maybe, I don't know, we'll find out, okay? So is that good enough? I don't know. I couldn't tell you. But those are the things that you are. And finally, something that you have. Now, this is where you've seen most of the development of authentication technologies, and something that you have. This can come down to an RSA token. It could come down to an app that runs on your phone that gives you an authentication token. It could be a smart card. You could get you might have a device that sends you a text message. There's lots of these, something that you have. In fact, there's tons and tons of these tokens that you can buy from lots of different companies that would sell you an authentication token that you can keep in your pocket, and you can use it as something that you have. Now, these types of tokens work off of crypto, and they basically have an algorithm within the token. They can either be time synced or they can be event synced. And so the way they work is basically every time you push that button on an event synced timer, okay, it generates a brand new token. And on the server, it has a window. It says, okay, in the last, you've got 10, and it could be as wide as 10. These are the passcodes based on this cryptographic algorithm that you can use within this window. And usually it's somewhere in the neighborhood of 10. So as soon as you use it, the window slides down to the last one, just below the last one you've used. So if you accidentally press that button a couple of times and don't use it, or you press the button and use it and it doesn't get in, and you have a communication mishap, you still can get in with one of those codes within the window. The time sync ones are based on a time. And so most of your Google Authenticator ones, if you've used Google Authenticator, that's based on a timestamp. And so what happens is every 30 seconds, every minute, every 10 seconds, depending on the app, it will change that code based on a timestamp, which is also a cryptographic algorithm. And that cryptographic algorithm has a key on the back end, just like the event-based ones. And that key is what's secret. And then that key exists on the server and it exists on your device. And basically it generates that token so you can authenticate back to the server. So why do we do this? Why would we need multi-factor authentication? Because static passwords are really easy to compromise. And once they're compromised, it's a done deal. Once that happens, your hacker's in and it's over. In fact, according to the survey on digital identity by Centrify, over a quarter of the respondents said that they enter a password online more than 10 times a day, which is potentially 3,500 to 4,000 times a year. Now, you and I probably do that even more, okay? But the problem is what happens is we get into this mode of we'll just type the password in, and most users do that. Well, the password prompt comes up, we type it in. We don't think about what it really happens on there. It's kind of like muscle memory, okay? So we get into that mode, and because of that, it's so easy for our passwords to be compromised by social engineering attacks. 42% of the respondents in the UK and 37% in the US say they create more than 50 new accounts every year. It's a lot of accounts. It's a load of accounts. Now, to top it off, that 2 in 5 people in the UK have had an online account hacked in the last year. Now, how many of those do you think are using the same password across all those accounts? Okay? All right, so 73% of online accounts are guarded by duplicate passwords. All right, so one password to rule them all, and 54% of people use 5 or fewer passwords across their entire online life. Now, there's a whole other talk we could talk about password managers and the benefits that they can provide, and the major benefits that this can provide to your users, so they don't have to remember a million different passwords, but that they can have different passwords for every single account. But that's the topic for another discussion. So in a report by SafeNet, 98% of respondents have members of staff that required mobile or remote access. How many of you have a VPN in your organizations? Okay? Now, I'm not going to ask each of you how many of you use dual-factor authentication to get into that VPN, but I will tell you that if you're not currently using dual-factor authentication to get in that VPN, you are opening the door to be compromised. It's an open invitation, because all it takes is for one of your users, to lose that password. And that's it. It's done. Okay? So, according to Symantec, 80% of security breaches could have been prevented simply by enabling dual-factor authentication. So, what are the pitfalls of dual-factor authentication? Because there are some, and there's some challenging ones, and some things that we don't know quite how to deal with. Well, first of all, the highly adopted text message. We know that lots of companies love to use text messages. They think that this is the greatest thing since sliced bread. We can make dual-factor authentication work great. All we have to do is send them a text message. Just give us your phone number, and away we go, okay? Well, the problem is this. The SS7 network, which is operated by telecoms, they provide basically an interface between all the different telecoms out there. And that SS7 network has different protocols on the network that says, hey, I currently have this phone number behind me, okay? Or I currently have this phone number behind me. And because of those types of protocols, if someone can breach that network, they can advertise and basically take over a phone number. And they can have all the text messages and even the phone calls rerouted to that location. So that means that you don't even get that text message. Someone else gets it. So in the event that they get a couple of pieces of information, they get your username, your password, and your phone number, which they may be able to do with social engineering, at that point, they can compromise your digital online life if you're only using a phone number as a dual-factor authentication piece. So that's number one pitfall. And you know, the challenging thing with that is it's been reported and noted since 2014. And we still haven't seen significant changes in the industry. So keep an eye on that and be aware of that. It's time that we get away from it. Social engineering is the next major issue. Now, a lot of us went to dual factor authentication to prevent social engineering because we wanted, hey, you know, if you're going to put in that code, well, it's going to expire and it's not going to work. But what happened is that the miscreants out there got smart enough to say, well, we're not just going to stuff all those codes in a database anymore and use them later. No, why would we do that? When we can script this entire process. And so what will happen is you may log in, and then the hacker's going to have a script that's going to run on the back end. As soon as you pass those credentials in, it's going to immediately turn around and use those creds to authenticate them. And that could redirect the user back to the login site in which the user thinks, oh, there was a glitch in the system, it just wasn't working, let's try this again. And they're not going to think a second time about it. You're going to be done. At which case they've compromised the account, they can set up any backdoors that they want, and away they go. So Google and Yubico got together and said, hey, we have got to come up with a solution for this. And this is what they developed. They developed something called U2F. Okay? And U2F, Universal Two-Factor Authentication, is basically a solution designed to mitigate this social engineering attack. So when we use a smart card, okay, have you ever heard about how a smart card works? There's actually a challenge or response that happens. And so it's authenticated. It's an authenticated process, not only by the sender, but also by the receiver. And they authenticate against each other. Okay? Otherwise, nothing happens. Well, they said, well, why can't we do something where it can be authenticated both directions? Not just one, but both directions. And so what they did is they came up with this little process right here. That you type in your username, and I don't know if you can even read that, but from the browser, you type in your username and password. That goes out, verifies the passwords, it generates a challenge, sends the challenge back to the browser sends the challenge to the device, okay? The device gets the challenge and generates a response to that challenge, okay? So at that point, the device is authenticated based off the challenge, sent a response. The response goes all the way back and verifies that response. And so now we've eliminated this social engineering capability, okay? And this is technology that's right on the forefront. It is being actively developed and it's being integrated into many systems. So take a look at it if you haven't heard of it before. Number 3, I lost it. I broke it. It fell in the toilet. I can't tell you, or I got a new phone and the other one's gone. I mean, I can't tell you how many times I've gotten a phone call, hey, by the way, my dual-factor authenticator is no longer working because I got a new phone. It's like, great. Okay, well, when can you stop by? It happens a lot, and it changes. And they lose it, they break it, and then they want access immediately. So this is a major issue. How do you handle this? There is no good answer to this. And I wish I could sit up here and tell you, hey, I don't know how to solve this problem. But I do know that if your users will report, hey, I lost it, okay, I lost my authentication token, then they need to report that back to you so you can turn that off so that that authentication token isn't used by a miscreant. Okay, time sync issues. This is not, this sometimes can be challenging with the smartphones. It's not usually, because most of the time the smartphones get their time from a cell tower somewhere. But with the old devices that you get that are actually an embedded device, like from RSA or SafeWord or any of those that create an embedded hardware token, what happens is you get out of time sync. And this happens when you fly a lot. It's a crazy thing. You would never think, hey, these clocks are going to get so far out of sync it's not going to work. But what happens is because the gravitational pull from the Earth is actually different in an airplane, it actually makes that clock run faster. Would you believe that? And after so many flights of so much time, eventually it gets out of sync and stops working. It's a crazy thing, but it actually does. And so that's another issue that you run into with those types of applications. You also have the event sync issues. And this usually happens when your kids get a hold of your token and they go, what's this? What's this? What's this? What's this? Cool. New numbers every time. And about 30 or 40 clicks later, they drop it on the floor, and you find it on the floor and go, what the? And then it doesn't work anymore, okay? Now, those are usually easy because they're usually in your software. You can go back and say, okay, tell me the next 3 numbers that it gives you, and you can resync it up. But this is a challenge as well, okay? Then you also have the wonderful multiple users are using one account, okay? And so your users get used to this. Well, they may get this pop-up on their smartphone. Hey, somebody's trying to log into your account. Well, if they've got lots of other people using the account, they're just going to say, okay, that's fine. Okay, maybe back in the day they call them, are you trying to log in the account? But eventually that gets to be too much of a problem. Okay, that's fine. All right. So obviously you want to have every user have their own account. So wrap up. Man, I made this really short, so we're going to have to just do a Q&A at the end. Multi-factor authentication is awesome. It's awesome. And in fact, there's lots of ways you can implement this in your organizations. One of the ways that you can implement this is easily with Google's dual-factor authentication. How many of you have tried the Google Authenticator app? Okay. Did you know that you can use that to authenticate people on your VPN? Do you know you could do that? There are plugins out there, and if you go to Google and you type in PAM, Google dual-factor authentication modules, you can take a PAM module and you can integrate it into a free radius server, and then that free radius server can host all your authentication for your VPN. And it's really easy to do, and it doesn't cost you a dime. You just need to have somebody that has a little bit of knowledge working in Linux to do that. And it's free. There's lots of other solutions out there that do cost you money, and they're not cheap. But if you don't want to go with the freebie route, that is the route that you've got to go. Because if you've got people jumping into your network, okay, and they can access protected and confidential information from the outside world, even if it's not over a VPN. Say you've got a service that sits in the cloud, and that service gives you access to all sorts of sensitive information. At that point, if you're not doing dual-factor authentication, you've got a major problem. And so my plea to you, okay, in this short 15, 20-minute talk, is that you take dual-factor authentication and use it. It's free if you want it to be. It can be paid if you want it simpler. But ultimately, using dual-factor authentication is going to help you. There's lots of options out there. The Ubico makes some really, really cool gear out there. They make the new ones that I told you about, the universal two-factor authentication devices that actually have a challenge response. There's lots of stuff out there. There's lots of hardware out there that's open source and free. Take a look at it. Make sure that you spend the time looking into that equipment, looking into that software, because in the end, if there's one single thing you can do with authentication other than train your users to use good passwords, okay, this is the next best thing that you can do to stop people from having their accounts compromised. Okay, are there any questions? Man, I must have answered all of them, or I've just totally blown over the top all of you. Yeah. Uh-huh.
What is the language or keyboard layout support? I'm a Dvorak typist.
Uh-huh.
And I've pressed those responses before U2F was standardized, and I would get the server would get a token in a layout that the format headers that is not expected because it's using Dvorak.
It's getting Dvorak. Oh my gosh. That's a really great question. Mm-hmm.
What about other languages like German, Spanish, where keyboard layouts
Well, that is a really good question, and I wish I had the answer for you. I don't. I can tell you that the new tokens also utilize other things like NFC and Bluetooth. Although they haven't released a Bluetooth token yet, it is in the spec. But they have released an NFC token, and so like phone devices, obviously it shouldn't be an issue, but when you plug it in and hit the button, yeah, I can see how that could possibly be a problem. And I do not have the answer to that. You know what? I hadn't even thought about that. Okay. Anything else? Oh, do they? Okay. Apparently YubiKey has a post on their website. So there are some workarounds available for that. Sweet. Thank you. Okay, anything else? All right, I'm going to let you out 9 minutes early. Thank you.